Hello, everyone. I'll start by presenting a little bit of what we've been doing in Brazil in regards to our Constructicon. And I hope I can be fair to everyone that works there, because this is not only me, it's like everyone in the lab is working with that, well, to some extent. One of the things that I wanted to start off talking is how we created the data that we have there, that it's everything combined. So originally we had a FrameNet based on Berkeley FrameNet, and it was translated. We had a translation of frames and lexical units, but it has been expanded. We have domains, lexical relations. We have worked with multimodality now, of course, constructions, and we made changes to structure too. So because of that, we do have special relations of constructions and construction elements to, for example, frame elements and all of that. That is all to say that we've been bloating Berkeley FrameNet in a good sense. And again, what I'll be showing here is we are going to expand it a little bit more. So I want to talk about two main things. We have a contribution in the side of data, that is, we want to include constructions, frames, and comparative concepts in the same database. And we do have a contribution in the algorithm part of it, that we are proposing a way to assign scores, similarity scores, to two constructions independently of their language. So when we started working with comparative concepts, one of the first things we did, we took Croft's glossary of terms, the one he mentioned that it's not going to be published, no, physically. So we took all of those concepts and we created a database with it, following their title, names and descriptions. And these are the numbers. In total, we have over 800 concepts. And then we started to create relations between them and started to organize them in a hierarchy. So we started reading through the manuscript, and every time we mention that something is related there, we create this relation. So we have two main types now, just because it's so hard to say what is that relation exactly. So we mainly kept simple. So we do have a subtype. So this is when a construction, of course, is a subtype of another, and a more general relation, which is just associated to. This relation, sometimes it can be a lot of things. It can be like, maybe this is part of something else. So this construction is a part of another construction, or maybe this is prototypically the strategy used for that construction in some language, all of those types of things. But we haven't really expanded this type of relation. So we go through the manuscript, make those relations at the end of each chapter. So for example, we have a chapter for modification. We would just look at those hierarchies and see if they made sense. Then, I'm sorry, this is repeated. So then we revised all of those hierarchies based on the type here. And by type, I mean just semantic content, the information structure, strategies, and constructions. I'm calling it type here just to make it simple, although they are related to each other in specific ways. And we ended up with this network with almost, for construction, almost like 800 relations, of which we see over 300 subtype of relations, and we see more than 400 of other types the associated to. Of those relations of 464, 63 are between constructions themselves. So it shows that like they are related in other ways. They are not subtypes, as I mentioned, for example, the particle. And in general, for the other types, and when we look at all of them, we do have more than 1,500 relations. So again, 903 of subtype of, and over 650 for other types. Then we took this database and started to use it, as Ben and Thiago was talking about, to think about like how can we compare and maybe align those constructions to give them scores of similarity. We first had to associate the CCs to the constructions in our database, of course. So this is something that was done for this work that, again, Thiago and Ben presented. You see that we are sharing the same things in our presentations, but also to the argument structure constructions that we had in FrameNet Brasil. So those were like 11 constructions, but we haven't used them yet for any type of comparison. And since we have a network, we opted to use an algorithm that would take advantage of that. So again, as it's common in our project, we adapted the spreading activation algorithm for that. I decided to show you this in a very graphical way, because I think it might be simpler. So here we do have color-coded different types of comparative concepts. And here we are assuming that the frame is a comparative concept, although this can be discussed. So there you can see sufficiency. It is a subtype of frame. That is a subtype of semantic content. But we see others like necessary participant sharing. And we also see like a dotted line to indicate that this is not subtype, but an associated to. So for example, the gap strategy is associated to the relative clause constructions. So we took, in the same example that was presented before, we took an infinitival relative modal construction of English and related to the comparative concepts. The way the algorithm works is by assigning energy to the construction node first. So here we have an energy at a time step zero, that is 1, so maximal energy. It is spread to all of the related concepts. Sufficiency directly related, relative clause construction and gap strategy. So at time step 1, we see 0.7. This number is arbitrary, it's parameterized. And then each of those will transmit the energy, decaying a little bit to the next. You can see that relative clause construction was kept at 1 because it received energy in the first step from the construction, but in the second from the gap strategy. So it's being reinforced. So it's like saying that relative clause construction is a very important comparative concept for this. And we repeat this process until we arrive at a certain time step that we have nowhere else to transmit energy. So of course, we can configure our maximum time step. Here is T. We can configure how much the energy dissipates and how it is transmitted, also based on the relationship type. But these are things we haven't really tested yet. So to compute the similarities, we simply take the energies of 2 different constructions when we apply this method and use cosine similarity. That is very common in computational linguistics, especially to compare vectors, because it looks at the angles, not the absolute values. And to wrap it up, so I just wanted to show that this is our main progresses right now. We have the comparative concept network connected to our Constructicon, sorry, and the algorithm to assign the scores. However, we have not really checked that against a large-scale experiment. And by large scale, I mean in every sense, with this more complete network, because the one mentioned by Thiago and Ben was smaller, but also with more constructions, more varied constructions. And we hope that from the workshop here, we can at least discuss those challenges and find directions to improve our data structure for the comparative concepts to fix those relations, because there are a lot of them, and some need to be discussed to discuss the algorithm parameters, and also if it's appropriate, and discuss the applicability of other metrics for similarity. And that was it.